Hey guys, today we're going to talk about logarithms and logarithmic functions. But first, let's review what an inverse is. So an inverse of a function happens when you switch the input and the output. So x is the input, y is the output. So when I switch those, I get x equals 3y minus 1. And then I'm going to solve for y to find what that inverse is. So I'll add that 1 over to the left side, so x plus 1 equals 3y. And then I'm going to divide both sides by 3. So x over 3, that's 1/3 x, plus 1 over 3, 1/3, equals y. So this right here is the inverse. Okay, so an inverse happens when you switch the input and the output, or the x and the y. Okay, so next up we are going to graph an exponential function. Okay, we're going to start with an xy table. Okay, and we'll start with x equals 0. And anything to the 0 power is 1. X equals 1, so 2 to the first power is 2. X equals 2, 2 to the second power is 4. 2 to the third power is 8. And 2 to the fourth power is 16. So we go up to 13, 14, 15, 16. Okay, so this is the right side of the graph. Okay, and I'll put an arrow on that end. And then the negative 1 power. 2 to the negative 1 power is 1/2. 2 to the negative 2 power is 1/4. 2 to the negative 3 power is 1/8. And it's just going to continue getting infinitely closer to an output of 0. It will never actually reach it. It just gets infinitely close. So that's what our graph will look like. Okay, so that's the graph of that exponential function. So next up, we are going to graph the inverse of that function. Now, an inverse happens when you switch the input and the output. The x's are the inputs, the y's are the outputs. So here, where we have a point of 0, 1, in the inverse, we're going to have a point of 1, 0. And we'll have a point of 2, 1. And 4, 2. 8, 3. 16, 4. 1/2, negative 1. 1/4, negative 2. And 1/8, negative 3. Okay, so we'll graph all of those points. Okay, now I'd like you to notice that when you graph an inverse, what you actually get between the original function and its inverse is a reflection over this line right here. And this line, you may recall, has an equation of y equals x. An inverse and its original function are always a reflection of each other over the line y equals x. Okay, so the equation of the original function, its inverse has an equation of x equals 2 to the y power. Okay, so we just switched the input and the output, the x and the y. So the equation x equals 2 to the y power is called it's the inverse, but it's also the logarithmic function. And it can be written as log base 2 of x equals y. And we'll talk more about that notation as we change the page to the back side, but it's read like this. Log base 2 of x equals y. I'm going to graph both of these functions on the calculator. This original function, y equals 2 to the x, and the inverse, x equals 2 to the y. Okay, so in y equals, I'll put 2 raised to the x power and graph, and we should see this original function. Okay, then I'm going to graph the inverse, x equals 2 to the y, but when I go to y equals, the only option I have is y equals. I don't have an option for x equals. So I'm going to use this logarithmic form. So I will graph y equals, and then I'm going to use this log button right here. Log, and I'm going to type it in as log x, and I'm going to close that, divided by log 2. And you'll learn later on in the unit why it is that I'm actually typing it in like that. But when I hit graph, there it is, that log form graphed this inverse. Okay, so now we're going to talk about going back and forth between exponential form and logarithm form. Okay, so in exponential form, we have this, b to the x equals a. So that b is the base. A is called the argument. Okay, sometimes people call it the answer. X is the exponent. So the base to some exponent equals the argument. In log form, it looks like this. Log base b, and I should have made that a little bit lower, log base b of a equals x. Okay, so we've got our base right here, our argument here, and our exponent goes here. So it's log of the base, or log with a base of an argument equals the exponent. Okay, so we're going to practice writing these in equivalent forms. So we've got 5 to the negative third power equals 1 over 125. And in log form, that's going to look like this. Log of the base, so the base is here, it goes after the word log, so log base 5, and then the argument, which is here, so 1 over 125 is the argument, equals the exponent. The exponent is here, that is -3. So when you see something in log form, it's kind of asking a question. It's asking 5 to what power is 1 over 125? Okay, so 5 to what power makes 1 over 125, and that power is the -3 power. So there's your answer, -3. Okay, so then we've got 4 to the second power equals 16. So that's log, and the base is 4. The argument is 16, and the exponent is 2. So what this one is asking is 4 to what power is 16? 4 to what power is 16? And that power is 2. So these are the log forms. I'd like you to pause the video and try the two here on the right side. So we have 7 to the second power equals 49. So we've got a base of 7, so that's log base 7, an argument of 49, and an exponent of 2. 7 to what power makes 49? The answer is 2. And then we have a base of 2, so log base 2 of the argument, 32, equals 5. So this one is asking 2 to what power makes 32, and the answer is 5. So these are the equivalent log forms. Okay, next we're going to start in log form and rewrite in exponent form. So we've got log base 4 of 16 equals 2. So the base is 4. Next up is the exponent, which is 2, and the argument is 16. 4 to the second power is 16. Here we have a base of 2, an exponent of 4, and an argument of 16. 2 to the fourth power equals 16. And again, I'd like you to pause the video and try these two. Okay, so here we have 7 raised to the negative 2 power equals the argument 0.02. And then a base of 3 raised to an exponent of 4, 3 to the fourth power equals the argument 81. And our last section, we are going to convert to exponent form, and we're going to solve these equations. So we've got a base of 2, we have an exponent of y, and we have an argument of 64. So 2 to some power equals 64, and we're going to figure out what that power is. Okay, so 2 to the y power equals 64, so let's try 2 to the fifth power. That's not big enough. 2 to the sixth power is 64. So y equals 6. Okay. Next we have a base of 6, an exponent of y, and an argument of 6 to the sixth power. So 6 to what power equals 6 to the sixth power? When the bases are the same, on each side here, I've got a base of 6 on the left side and a base of 6 on the right side, then that means these exponents are also the same. So 6 to what power equals 6 to the sixth power? 6 to the sixth power equals 6 to the sixth power. So y is 6. And then 4 to the 5 over 2 power equals the argument of n, and we're going to use the calculator for this one. 4 raised to the, and I'm going to use the fraction, so that's the math key, and then over to number, I'm going to hit the up button to go to the bottom, and the power was 5 over 2, so 4 to the 5 halves power is 32. And one more time, I'd like to have you pause the video and try the 3 on the right side. So in exponent form, we have 3 to the y power equals the argument of 9. 3 to what power is 9? That's 3 to the second power is 9. Base of 9, exponent y, an argument of 9 to the second power. 9 to what power equals 9 to the second power? That would be 9 to the second power equals 9 to the second power. So y equals 2. And last up, 8 to the 4/3 power equals n. So 8 raised to the 4 over 3 power equals 16.